In this tutorial, we are going to build the game Lights Out on a hexagonal grid. We will also be making our own simple cell and make our own grid behavior. We start by making our own cell. In this case, we will be using a 2D game, so we can base our cell on the sprite cell class that comes with grids. Because we are using a hex grid, we will be using a pointy hex cell. To make things easy, we will start by duplicating the pointy hex example prefab. We will need to add a bit of logic to the cell, so we need to make a new cell script. We will extend this class from sprite cell, since sprite cell already has the functionality in to make cells change color. The only bit of logic we will add to the cell is whether the cell is on or off, and to change the color accordingly. We will keep the state in a private bool. We add a public property to access this value and change the cell's color when the value is set. One last thing, the cell's default on-click behavior will make it highlight when it is clicked. We will implement an on-click method that does nothing to prevent this. Back in Unity, we now modify the prefab we copied by replacing the old script with the new script we have just written. The next step is to create the grid. We add an empty game object and add the pointy hex grid builder script to it. We drag in our cell prefab, hit build grid, and we have a grid. The next step is to add our main game logic. We will do this in our own grid behavior, which is simply a class that extends from grid behavior, the same way components extend from mono behavior. Because we are working with the pointy hex grid, we must specify the point type as pointy hex point. We start by overriding the initGrid method that we will use to put in our logic for making puzzles for the player to solve. The grid property of the grid builder behavior gives us access to the grid. However, the cells are not of the right type, but it is easy for us to cast the values of the grid onto a new grid that contains cells of type lights out cell to make the grid more convenient to use. For now, we will only assign cells randomly. We do this by writing a for each loop over all the points in the grid and simply set the isOn property randomly for the cell at that point. We can then add our grid behavior to the grid, and as you can see, the cells are now randomly blue and yellow. The next step is to write a method that takes a point and toggle all the neighboring cell states. Because we want to access our lights out grid from this method, we will change the variable in the initGrid method to a field. We can then write the method, and all it does is to get all the points neighbors in the grid and iterate over them to toggle their state. The next thing is to add the mouse click handling code. We do this by adding an on-click method. This is called by the grid builder. All this method does is to call the toggle method we wrote earlier. Just before we test, we need to quickly set up the camera. It's the same as you normally need to do for a 2D game. Next, we change our random initialization code to use the toggle method instead, so that we know a pattern is solvable. For this, we select a random sample from our grid and simply take all those cells. Let's test. We see it's not working completely as we expect. We still need to initialize the grid properly. But before we do, let us quickly make the patterns a bit more symmetric. Instead of just toggling the neighbors of a random sample, we will also toggle the neighbors of the reflection of those points. That way, our grid is always vertically symmetric. To fix it, we simply need to set all the cells to the off state before we make the pattern. And now everything works. The final step is to add a check to see if the game is finished. We add a method that returns false if any cell is still on. We then call this method in our update method, and if the game is finished, we simply change all the cells to red. We also add a bool to store this value. You can use this to block further input in the onClick method if you want to. And that is it.